Hello, my friends, and welcome to the final section of part 3 classification, where we're going to answer together a very important question, one of the most frequently asked questions in the data science community, which is, which classification model should I select, should I choose for my data set? And the goal of this tutorial is to show you how with any data set, regardless of the number of features you have in the data set, well, I will show you how to select quickly and efficiently the best classification model. All right, so that's why here we're back into our machine learning A to Z model selection folder, which is a separate folder compared to the whole machine learning A to Z folder with all the codes and data sets to figure out how we're going to select the best classification model. All right, so here we are in the classification folder of our model selection, big folder. And as you can recognize, in this folder, we have all the classification models that we implemented together all along this part 3. You have all of them. However, I slightly modified them. But the only thing I did, with respect to what we did before, is that I removed all the print, to alleviate or lighten the implementation so that we can see more clearly. And also, of course, at the end, I removed the 2 cells where we visualize the training set and test set results, right? Because remember, these visualizations only work when you have 2 features. And here, as you can see, I took a classic data set with many features. You can see all of them here. So these are all the features and this is the dependent variable. But you can see this data set as a generic data set containing many features, all with numerical values, right? We won't do any kind of specific data preprocessing, and indeed a binary dependent variable taking values 2 or 4. All right, so since we have the data set in front of us, well, let me explain what this is about, even if it doesn't really matter, because the goal of this tutorial is just to explain how to deploy efficiently all your classification models and quickly figure out what is the best one on any data set, regardless of the number of features. But let me still explain what this is about. So this is a classic data set which belongs to the UCI machine learning repository and which is about breast cancer. So in this data set, each row corresponds to a patient, different patients here. And for each of these patients, we gathered, well, first the sample code number, the clump thickness, the uniformity of cell size, the uniformity of cell shape, the marginal adhesion, the single epithelial cell, the bare nuclei, the bland chromatin, the normal nuclei, and the mitosis, okay? And all these variables are the features, from sample code number, even if that's not really a feature, up to mitosis. And with all these features, we are predicting the class, which tells for each patient if the tuner is benign, in which case class takes the value of 2, or malignant, in which case class takes the value of 4. All right, so that's what the dataset is about. You can find it on the UCI ML repository by the name breast cancer, and you can take the original version. But really, don't worry about all these features because, most of us don't understand what they mean. We're not doctors here, but we are data scientists. And even if we don't understand the domain knowledge here of oncology, cancer medicine, well, that's still fine because we can still build classification models to understand the correlations between all these features here and the dependent variable class which we want to predict, telling if the tumor of each of these patients is benign or malignant. All right? And so we're going to use this data set to deploy all our classification models in a flashlight, in a matter of seconds. And after just a few clicks, we will be able to figure out what is the best classification model for this data set. All right, great. So let's do this. Let's close this. And now what we're going to do in order to start the demo is, because this is a Google Drive folder to which all of you have access, and therefore you can't modify it, obviously. And so what you have to do in order to modify these cells, because we will have to enter the name of the dataset because these are all code templates. In order to modify these cells, you need to create a copy. So that's the first thing we'll do here. Let's do this quickly, You just need to do a right click and then make a copy for each of them. All right. Then kernel SVM, make a copy, logistic regression. So you see it's pretty fast. Sorry about that, but at least it only takes a few seconds and then you'll get all your copies in case you want to modify them, but I recommend to. All right, then your copies would go naturally to your main drive or, in the Colab notebooks folder. Here they just went into my drive, so all good. Now we're gonna open them all. So starting with the last one, random forest. All right. Then we're gonna open decision tree classification. Open. All right. You can open it with Jupyter Notebook also if you want. All right. Then we're gonna open naive Bayes. All right. Then we're gonna open Kernel SVM. Perfect. Then we're gonna open SVM, where is it? Right here, support vector machine, open. Then we're gonna open the k-nearest neighbors. All right. And finally, we're gonna open Logistic Regression. I went from the last to the first because as you can see, this is the way now we have all the files in the correct order.